Now we will introduce to Dr. Timothy E. Eastman. Formerly, he was associated with Geophysical Institute, University of Alaska, USA. So it is a privilege to introduce Dr. Timothy E. Eastman, a highly respected scientist and philosopher whose interdisciplinary work span the field of space physics, plasma science, and philosophy of science. Dr. Eastman earned his PhD in physics and geophysics from the Geophysical Institute of the University of Alaska in 1979, where he conducted pioneering research on Earth's magnetosphere. Notably, he discovered the low latitude boundary layer in 1975, a key contribution to our understanding of solar wind magnetosphere interaction. Over the course of his career, Dr. Eastman has published more than 100 scholarly articles across space physics, and philosophy. He has served in key administrative and research roles, including as a programmer officer at NASA between 1985 to 1988 and the National Science Foundation 1991 to 1994. In this capacity, he co-developed foundational framework for major interdisciplinary initiatives such as the International Solar Terrestrial Physics Program, the Interagency Space Weather Program, and NSF Basic Plasma Science and Engineering Program. Dr. Eastman's scholarly engagement with the philosophy span more than 4 decades. He is the lead editor of two important interdisciplinary volumes, Physics and Whitehead, Quantum Process and Experience, published by Sunny Press in 2004, and Physics and Speculative Philosophy in 2016. In 2009, he was honored with the Creative Advance Award by the International Process Network in recognition of his research bridging science and philosophy. His most recent work, Untying the Gordian Knot, Process, Reality and Context, published recently 2020, outlines the integrative logi framework and interdisciplinary approach that draws on development of physics, logic, semiotics, and process philosophy to explore questions on natural philosophy. Dr. Eastman also founded and maintains the educational resource website plasma.org, dedicated to plasma science and its wide-ranging application. Please join me in warmly welcoming Dr. Timothy E. Eastman.
Okay, well, thank you for the opportunity to present this material about plasmas and cosmic process. This is based especially on uh, two works that are on the list: Untying the Gordian Knot, which was just mentioned in the introduction, which came out in 2020, and more recently, a essay published by Perry Perspectives in January 2025 titled Orders of Possibility and Actuality. And so the Untying the Gordian Knot includes within it a very extensive critique of mechanistic philosophic approaches or also and scientism, which I recommend to you for that kind of focus, in addition to its effort towards working towards a new natural philosophy. Next slide, please. So I'd like to dedicate my presentation to Professor Jayant Narlikar, who just passed away only 2 weeks ago. I very much appreciated and greatly benefited by his great work with Fred Hoyle and others. He was an outstanding physicist, always humble. He consistently explored alternatives to his works in cosmology and astrophysics. He always checked his own steady state model with observations, and he's always had the deep intuition that the universe was not really of simply 13.8 billion years of age and some kind of finite span like that, but was really of an indefinite time scale, which I will come to. That my argument is that his intuition was likely quite correct. Next slide. So my key points to this presentation are that There's a Big Bang research program, which itself as a program is not falsifiable as such, sort of in the sense of the philosopher of science Imre Lakatos, but at specific quantitative models, such as the lambda CDM model in particular, which is sometimes referred to as the standard Big Bang model. That specific predictions of it quite recently have very definitively failed, and that there's an alternative model that does succeed. There's many cosmology models these days. There's well over 30 such models, and it's been presumed that the Big Bang model, the lambda-CDM model, is the preferred one, with high confirmation. Well, this was roughly the case up until about 25, 20 years ago, but over the last 20 years, it's increasingly been challenged, and especially in the last few years with the Hubble results and the James Webb Space Telescope results. So the results I interpret from all of these new developments is that the universe really is of indefinite age, as Professor Narliker suggested for us, perhaps trillions of years or more, and not and that both gravity and electromagnetism, electricity and magnetic effects, and plasmas, understanding these and working with such uh, concepts are required for contemporary cosmology, not just to focus on gravity. That a key breakthrough has come recently with regard to understanding redshift. That's a key element for understanding these, interpreting the data from recent quantum spectroscopy research, which I'll make reference to, that we have actually observed filamentary or vortex structures of space plasmas at all scales. And and then turning now with a focus on the philosophic side, that I will introduce to you a new non-reductive natural philosophy for the 21st century that makes a distinction of a fundamental order of actuality and of possibility. And so next slide. So this natural philosophy I point to and develop in some detail in my work on tying the Gordian knot from 2020, weaves quantum physics triads of input-output context, fundamental logic, complex systems theory, semiotics or the theory of signs, and process relational philosophy to demonstrate how potential relations, both local and local global, can provide a grounding for causation, emergence, and physical relations, that is, quote, laws. Its ways of knowing incorporates both context emphasis, as in Hearts and the Humanities, and context independence, that is, the emphasis in scientific representation, and argues for the inevitable role of ultimate context, that is, meaning and the spiritual dimension, as part of a transformative ecological vision. Next slide. So this logoi framework, or it's basically a relational framework, using the Greek term logoi as a way of labeling this, that the real, the most fundamentally, should be considered as both the actual space-time particular givens, the hard whatevers of the world, the actualized things, the actual plus ontic possibility, possible relations, or possibilia. And that to consider laws not somehow as God-given things, but as physical relations that arise as a result of constraints and possibility, which is indicated through the principle of least action and other ways of deriving some basic physical relations. And I argue that they're fundamental ontic levels, that they're both epistemic and ontic considerations. In the previous presentation, some very scholarly work was done to focus on epistemic aspects of systems. But here I wish to argue that there's both epistemic and ontic, and that in the fundamental ontic levels arguably are a quantum substratum or pre-space, a veiled reality, as well as an actualized time-space quantum world, the experiential now. That experiential now being and as a subset of that experiential now, classical models provide a modeling, a representation that's very powerful applications, but are only approximations, never a basis for fundamental ontology. Next slide. So at the foundational level, I would argue that we need to have, and this several people have argued this case, especially Hans Primus, Michael Epperson, and Ilya Safiris, Ruth Kastner, Gordon Kaufman, and others, that we, at the most fundamental level, need a logic of actualization, or what's called a Boolean logic, after George Boole, a mid-19th century mathematician, in which there's only two values, either true or false, either things are one or zero, on or off, in which you don't have an in-between. That is an excluded middle logic. And you need a logic of potential relations, or potentia, a non-Boolean logic or free logic that enables the possibility of maybes, or the in-between. Quantum physics arguably requires both a logic of actualization and a logic of potentia, unless one insists on actualism and appeals to multiverses. Next slide. As well, I would argue that quantum process is fundamentally triadic, that fundamental logic, philosophy, and human experience, quote, mirror the general evolution of quantum states from actual potential states, rife with quantum superposition, to a return to actualization. Modeling this fully involves triadic structures, including logic of both potentia and actualization, always the triadic of input-output context, not just a simplistic input-output dyad. This is brought out in some detail in a work I did with philosopher George Shields on the topic Triads as Primal, published in Process Study Supplement, which is available online from 2023. Next slide. So a summary of the Logoi framework that I bring out in my work on tying the Gordian knot in some detail. At the top level are the notion of process, that is input, fundamental quantum process, input-output succession within context, constraints and potentia. If logic considerations I've already referred to, a logic of actualizations and a logic of potential relations, including potentia with multi-valued logics, and also relations at a most fundamental level, constitutive of process, both considerations of part whole, local global, internal external, and relations of relations, and that is semiotics, the theory of signs, extension, and relations in category theory, a major aspect of mathematics, considering mathematics fundamentally as theories of relation. Thus, we have two fundamental onic levels, a veiled deep pre-space reality and our experiential now, that is actualized space-time quantum events. And with this, we can look anew at considering a broader mind space and understanding of consciousness, whereby the brain acts as a filter, and that consciousness somehow isn't just merely brain states, but that the brain is part of a broader mind space, and consider anew how minds can tap into potentia, achieving in however limited a way some connection with ultimacy, meaning, and value. Next slide. So from here we've focused on quantum process so far, so let's transition to the space plasma environment, the nearby astrophysical environment, onto broader astrophysical and also finally cosmological issues. Key to this point is a development, quite recent development, that has shown, as Andreas Schlatter and Ruth Kastner have shown, that Einstein's gravity physics can be derived from quantum field theory, and thus is not equally fundamental to quantum physics, as presupposed in many efforts to work towards a united theory of the fundamental field. That effort towards a unified field theory throughout much of the 20th century simply presupposed that quantum physics and relativity theory were at equal level. This result instead argues that the relativity is actually derivatives. Further, in contrast to the Big Bang research program, in which multiple hypothesized entities, that is dark matter, dark energy, inflation, black holes, have evaded observational test or confirmation for decades, I will outline here a new gravity plus plasma model that requires no new physics, that can explain basically all cosmological observations to date, including the most recent observations representing exceptional challenges to the popular Big Bang model, such as direct detection of galaxies at the very limits of observation, at the very limits of redshift that are fully formed, that had to have evolved at least a couple billion years, which then pushes the timescale well beyond the standard Big Bang limit of some 14 billion years. Next slide. So getting back to some fundamentals about primary natural systems, we often in school and high school learn about solids, liquids, and gases. And this is all in terms of neutral states, solid being the more compact, hard kinds of conditions of things, fluid being expansive, whether in the form of uh, neutral gases or fluids in a normal manner. But also there is plasmas, which arguably is either a forced third state or a fourth state, depending upon how you consider it. If you think in terms of solids, liquids, and gases, then plasmas represent a fourth state of matter uh, in terms of naturally occurring, common naturally occurring state. Of course, there's other exotic states, over 30 plus exotic states, but in terms of uh, common naturally occurring states of matter, there's basically the solids, liquids, gases, and plasmas. But I'd also like to think in terms of systems, that there's condensed matter systems, fluid systems, which can be represented by what's called the Navier-Stokes or fluid uh, theoretical framework, and electromagnetic systems, where you have to bring in the Maxwell-Boltzmann relation and the Maxwell equations to help describe such systems. So in terms of systems, we really have these three. Next slide. So space plasma physics is an area that has been my area of specialty throughout the 1970s through my retirement this past decade. And they're multi-scale from laboratories to solar system to galaxy and beyond. And they're basically, in certain aspects of them, are scale-free. Uh, that is, they provide exemplars at each one of these scales. Um, Goldblatt and Potts, who published Principles of Minute Hydrodynamics, the major aspect of plasma physics, from Cambridge Press 2004, they state the nonlinear interaction of plasma and complex magnetic structures presents itself as an important common theme of lab and astrophysical plasma research. Large-scale tubular magnetic structures occur that move with the plasma so that magnetic forces are transmitted with the fluid. One could hardly imagine a larger contrast with central electrostatic and gravitational forces decaying in vacuum with distance as 1 over r squared. So there's aspects of plasma physics that are dynamically important that are neglected by just setting aside and focusing on gravity alone or a central force approach. Next slide. So in the plasma universe, so we have, so to speak, there's the visible and the not so visible universe. And the plasma universe, so to speak, both of these stars and everything we see, essentially all the emitters as we look out, uh, the emitters of the photons themselves are most often a plasma source. And as we look at the sun, we see the sun, and the sun emits a broad range of energies and peaks in the visible spectrum, and our eyes have evolved and adapted to take advantage of that peak in the visible spectrum. But there's shorter wavelength in the ultraviolet and X-ray. There's longer wavelengths in the infrared. And here's a picture of a prominence of the sun taken by spacecraft in the ultraviolet, exhibiting the plasma universe. Next slide. And the sun, if you see it in, say, both the ultraviolet in this central disk, uh, which shows various prominences, but superimpose an X-ray photograph of a coronal mass ejection, a CME, you can see this dramatic CME coming out from the sun to the right-hand side here, along with all of the outflow of feeding the solar wind that you see in all directions around the sun. And this feeding of the solar wind is always going on. You only once in a while have the kind of solar storms or solar flares or coronal mass ejection that you see in this dramatic case. Next slide. Now, as the outflow from the sun goes out in supersonic speeds in every direction, this plasma outflow, then you have interaction with various obstacles, with moons and planets. And here we have a artist depiction of how the Earth is embedded in the upper center of this artist illustration, and how the Earth's magnetosphere forms with a shock wave out in front of the Earth, and then you have a blowback of this magnetic or plasma environment to a long magnetotail, and the Earth's radiation belt and the inner environs, and you can see the Earth depicted as a small blue dot in the middle of that. But Earth is effectively a great comet if you could actually see its full magnetosphere. And indeed, every obstacle in the solar wind flow is effectively a great comet, so to speak. Next slide. And thinking about plasma's characteristics and in their space plasma implementation, that they're multi-scale, a variety of scales in density and temperature and scale length. There's filamentary, there's directionality, there's connectivity and interactivity. And in 4 successive slides, I'll illustrate this. Next slide, please. So here's the way in which multi-scale from here in number density per cubic meter from 10 to the third to 10 to the 33rd, tremendous scale in number density, tremendous scale in temperature. This illustrates particular examples from very tenuous space plasma and auroral features to the very high densities needed for fusion, as in the center of stars and in fusion experimentation. Next slide. And filamentation is illustrated by the aurora at both the northern and southern polar cap that are dramatic signatures of the plasma environment from the ionosphere, magnetosphere on out. Next slide. And then the directionality exhibited by the lightning that we all experience at times during dramatic Earth-based tropospheric storms. Next slide. And then how it conducts electricity. Here's a plasma experiment in Albuquerque, New Mexico, that at one point really dramatically showed the visible forms of conduction at very high current. Next slide. And then interactivity. Here, another illustration of the Earth and its geomagnetic field with the inner field displayed in the red and the yellow, and then the blue and green illustrated the outer ring current and magnetosphere with the solar wind approach and sun from the right-hand side blowing back to magnetotail on the left-hand side. Next slide. So the current with cosmology and astrophysics have traditionally focused on neutral bodies and gravity, which is reasonable as a first approximation. However, the approximation of plasmas as fully shielded ionized gas, implicit in simplistic references to gas and not to plasmas, is invalid everywhere direct measurements have been made, where we've taken spacecraft with plasma magnetic field measurements near Earth and indeed to the outer planets and throughout the solar system and done direct in situ measurement. The approximation that the plasma effects can be fully shielded out is just simply not the case. There are 2 long-range forces of relevance at astrophysical scale, both gravity and electromagnetism. Next slide. So the limitations of modern cosmology is that we lack a unified field theory. We don't really understand how gravity and quantum theory relate. And then, as I noted more recently, it looks like gravity is derivative from the fundamental quantum field theory. And further, cosmology is intrinsically an historical science and lacks direct experimental testing. You can't replicate it and repeat it as you can in a laboratory. And data in cosmology are in general limited to remotely sensed photons. There are no direct in situ measurements, that is, in place, right in the place, as possible in solar system, space physics, or planetary science. And most existing cosmology models focus on only one long-range force field, gravity, and ignore effects of plasmas and electromagnetism, assuming incorrectly that such effects are 100% shielded out They are, mind you, substantially shielded out, like 1 in 10 to the fifth, 1 in 10,000, 1 in 100,000, but they're not 100% shielded out. And the fact that they're not 100% shielded out has major impact. This is developed in some detail at cosmology.info, the cosmology group. Next slide. So one particular test, and there's multiple tests like this. This is an example that's dramatic with respect to the predictions of the Big Bang, specific quantitative Big Bang model of how the surface brightness of galaxies, it's called the Tolman test. And and the prediction of it gives rise to this red line. That's the specific quantitative prediction of the standard lambda CDM Big Bang model as currently represented, in contrast to a sets of measurements that I assisted Eric Lerner beginning around 2005 when I worked at NASA Goddard Space Flight Center, working with the National Space Science Data Center there as a group manager. I helped him gain access to galactic data to do this surface brightness test. And then he's followed up with multiple checks over the last 20 years, most recently with a paper about 2 years ago, that ever more provides data to test this model. And here are the data points in this slide. And the data points map right around the result that the surface brightness is a constant at all redshifts, right up to very high redshift. And redshift is a change of wavelength of the photons as emitted by a source, and that roughly are scaled. So it's so the prediction of the Big Bang model is specifically falsified in a versus a non-expansion prediction. Next slide. Uh, Now, Lerner's galactic origin of light elements model, which I find most promising, is that it explains all basic observations without inflation, dark matter, or dark energy. We don't need these hypotheses. That all the light elements are created, as well as the heavier elements, are created by thermonuclear and cosmic ray processes in young galaxies, as confirmed by observations. The Big Bang predictions appear to be contradicted by a large number of data sets, whereas this model of Lerner's appears to be supported and not contradicted by any, but there are specific predictions in advance of the James Webb Space Telescope data that there would be fully formed galaxies at the very limits of observation. And that prediction turned out to be the case in contradiction to the lambda CDM model, which specifically predicted that you wouldn't have such galaxies. And but, however, that model requires a non-expansion redshift, in contrast to most cosmological models, which required expansion redshift. So that was a limitation because we didn't have such a redshift. Next slide. However, recent results have shown, well, indeed, Narliker, in his paper with Burbidge, 2008, in our view today, the most basic question to be answered is, do we really understand the nature of the redshift? This is the very last line of that book. It was emphasized by him. And sure enough, it turns out that the redshift, not having it correct, is a major issue. However, quantum spectroscopy lab research recently has revealed the spectral transfer redshift providing coherent and non-blurred redshift based on modern quantum electrodynamics. And the predicted redshift via tenuous electron space plasmas, as expected, however, will require, the direct testing will require significant improvements beyond the current technology. Next slide. However, with this redshift, both gravity and electromagnetism is then expected at all scales. And Eric Lerner calculates that a recently observed big ring of galaxies interpreted as a rotating electromagnetic plasma helix system using his 1986 model would be expected to have a radius of 1.2 billion light years versus about 1.1 billion light years as observed. So this is most interesting, a prediction in a paper some time ago that then these recent observations confirming it. And these observations are of a ring. You can see in this display, it's the blue circle, a set of galaxies, a pattern, a clear ring, and at the at the speed scale of typical, roughly the limit uh, astrophysical uh, dynamic movement on the order of 1,000 kilometers per second. In 14 billion years, in the nominal scale of the Big Bang, you'd only achieve a distance that's a fraction of the diameter of this big ring. In order for that ring to be created, it would require tens of billions of years at the minimum. Further, it illustrates the inhomogeneity of real systems at such scale. Next slide. So when you take and look at the most sophisticated recent telescopes, including the Hubble and James Webb Space Telescope, when you look at a region that appears to be completely dark and without anything, and you focus on that and do a long time exposure with the very best resolution, it turns out that this is the kind of thing that you see. You see galaxies without limit. You see clumping without limit at all cosmic scales. Of which in these inhomogeneities, the Big Ring is just the latest example. The result here that we're seeing is that the so-called cosmological principle, in which you insist on homogeneity and isotropy at the largest scale, as required to solve the Einstein general theory of relativity and apply it to the cosmology problem, is simply not the case. So therefore, you cannot properly apply Einstein's general theory of relativity to cosmology as presupposed in the Big Bang research program. So this real homogeneity, such clumping, is what the real cosmos gives us, not the idealized homogeneous concept of artificial models. Next slide. So force-free magnetic vortices are predicted in the space plasma domain and are directly observed throughout the solar system and beyond. This comes right from the pinch effect in space plasmas that inevitably occur at multiple scale. Indeed, arguably, it's been directly seen in stellar and galactic scale, as shown by this example of the Vela Nebula, and expected, because of scale free, to be true at all scales. So the combination of both electromagnetism and plasma effects and gravity in combination can create over billions to trillions of years a hierarchy of filamentary structures, in turn creating superclusters, clusters, galaxies, stars, planets. And in the long term, this process represents an evolutionary building up of the cosmos, not a running down. Next slide. So this illustrates all these scales from a different scale, but and this in log duration in years. So from millions to trillions to millions to billions to trillions of years at the longest scale here, as expected in the sequence of model of scale-free effects in Lerner's model. Next slide. Thus, I would argue that there's really consideration of deep time and possibility, and quoting Narlik and Burbage in their work of 2008, Facts and Speculation in Cosmology, quoting, "The day or night of Brahma, the creator of the universe, is equivalent to 4.3 billion human years, 4.3 trillion human years. Thinkers of the day did think of timescales far in excess of normal human lifespan." And then further, quote, "Our fundamental ontology now incorporates both an order of actuality and order of possibility," as I argue in my work, in Orders of Possibility and Actuality. The former evinces radical diversity. The latter's possibility amplifies diversity, and yet for such ultimacy in potentia requires a grounding, perhaps a kind of unity suggested by arguments for the absolutely necessary dimension of being, or Brahma. And with that, I'll close and be open for questions. Thank you.
Thank you. Thank you so much for your nice Very nice, inspiring, and integrative lecture, Dr. Eastman. It was really interesting to listen the content of this lecture. So we'll start with the Q&A. So maybe I start with asking that you describe a new natural philosophy based on events and process rather than substance. So do you see that this process worldview as more compatible with quantum theory and possibly with, consciousness studies?
Yes, indeed, I do. I think that there's developing in the recent couple of years quite a convergence of some work in consciousness studies and quantum and consciousness that and there's a number of players that have been looking at this. I'd like to call attention to a recent, at Perry Center in Italy, upon their 25th anniversary, is featuring a preview of a film called Quantum Convergence, The New Science of Consciousness, in the time frame of June 7th to 14th. So I encourage readers to maybe check on the Perry Center. I think it's perrycenter.com and check out that. It includes a number of rep, uh, of scholars discussing those issues. And further, the quantum process, I think, involves both, as I noted, actuality and potentiality. And the consciousness is calling attention to how there's aspects of both. The consciousness, so to speak, by definition, is the anticipatory capability to that which may be versus that which is, and the interplay of that, the self-awareness that's involved with that. And that distinction of actuality and possibility is how one addresses that. And to me, that comes out in quantum physics, in the physics side, and is also comes out with philosophic reflection, uh, including semiotics. Thank you.
Thank you. Thank you so much. And also thank you for the information. Okay. The question is from Dr. Bharat Pandey. He asks, Sir, actuality means what we can observe and prove, and possibility is what could be true or discovered in the future. In topics like space plasmas and quantum physics, where many things are still unknown and uncertain, how do scientists balance between what is real today and what might be possible tomorrow? And what do you think new technologies will change this balance in the coming years?
Well, I think it's always the case we need to apply a more than a little dose of humility with respect to what may be possible in the future. Uh, Here I was talking about ontic possibility as a way of thinking about the nature of the real, fully included. But of course, if we think about um, that the actualized uh, world we live in, our quantum world, there is a strong epistemic aspect, as emphasized in the previous presentation, about the limitation of problem of knowledge, both now and so forth. But we anticipate, we put together what we do know, and then we have extrapolations and suggestions about what may come in the future through anticipatory functions, short term, but maybe predictive capabilities, much of which we need to take with a grain of salt. As for the possibilities of artificial intelligence and quantum longer term, I'm very much a skeptic. That is, mind you, at fundamental information theory, there's both the issue of the syntactic information and semantic information. Syntactic information being that which you can put in a spreadsheet and numbers that you can manipulate, which is often what we think of as information. But there's also semantic information, the aspects of meaning and connection, semiotics, information, fundamentally both. Computers only work with syntactics. They only work with numbers and manipulating them. They only work by an algorithm working with that. So you see the ability to link to the semantic dimension and to make decisions based upon that is not available to computers as presently conceived, including artificial intelligence systems. So in that sense, artificial intelligence is both artificial, strong quotes, and not really intelligent.
Mhm. Yeah, thank you. Thank you for clearing that up. The next question is from Yanugu Nikhil from ISER Kolkata. He's asking, your use of Vedic cosmology and the reference to Brahma's deep time is very compelling. In your view, is this metaphorical, or do you see meaningful scientific parallels between ancient cosmological frameworks and modern plasma cosmology?
Good question. Well, that's a very good question. I enjoy the raising of that question. And myths are myths. On the one hand, they're not, so to speak, quote, real. On the other hand, they point to realities. They suggest ways of understanding that are with some deep wisdom. And I think that's how we should think of this, that here we have these ancient stories, these ancient mythological representations that have an element of truth, an element of wisdom that we should pay attention to. And Professor Narliker was very astute in paying attention to how the universe is likely of indefinite age, not of rather short span. And he stuck to that with his steady state cosmology. I think that aspect of his intuition is basically the case. So we can learn from such wisdom, but we need to be skeptical, as we need to be skeptical about any inferences, including ones based upon science in a limited way. So if you focus on science as nothing but, say, dyadic thinking and Boolean logic, we call that's scientism. And scientism is false because science more broadly and the reality more broadly is both the Boolean and the non-Boolean, both dyadic and triadic representation, both the syntactic and the semantic. Uh, so to collapse things to only one among a reductive collapse to only one among these pairings is a basic fallacy that's all too common in contemporary thought. Thank you.
One more question from Dr. Roshan Tiwari. He says, many of the models that you discussed, like the goal E and non-expansion redshift, offer explanation without relying on dark matter, dark energy, or inflation. What do you think such models remain outside the mainstream despite their explanatory success? Is it inertia, lack of awareness, or deeper philosophical commitments in cosmology?
Well, that's an excellent question, and the suggestions about um, all of those elements are part of it. Deep commitments to careers, to financial investment, to groupthink are contributors, but also just a matter of a typical education. In my field of space plasma physics, I was uh, chagrined to find out that most of the PhDs in my nearby University of Maryland in astrophysics often don't take the plasma courses that are right there from experts in plasma science. And so then they go on and make all kinds of excellent and interesting interpretations of cosmology based upon gravity physics and Einstein general theory relativity and so forth. But they'll talk about the gases and astrophysical plasmas, or they'll make other approximations without being aware of the way in which their own domain of application would be affected by considering both gravity and electromagnetism, not just to focus on gravity. And to consider alternative explanations. So there's the tendency to get into a rut in scientific thinking, and this is true in general. I get stuck in ruts, so I've been caught flat-footed with that. So one needs to be humble on this, and I wish to apply a lot of forgiveness of colleagues that can get a little stuck on dyadic thinking versus a more complex way of approaching these issues. Thank you.
It's still coming up. Yeah. So Rahul Patel from IIT Bhubaneswar is asking, is our thought, is it like possibilities and it reduces to one of them upon awareness?
Well, that's an interesting question. Yes, I think our self-awareness, our consciousness is, so to speak, a bridge of the uh, order of potentia and actualizations, that we're constantly at this inter interface. That's our lived experience. The immediate now is that at that interface everywhere. This is the yeah, I think human consciousness is such a pointer to that inevitable linkage of those fundamental realities, both the actual and the possible, and playing out at all times, and that there's different levels of anticipatory capability as developed by Robert Rosen in his work Anticipatory Systems and Complex Systems Theory, that we develop a model of the world, which model incorporates past experience, and that model is a way to, in terms of, say, ducking the ball that comes towards us or something, we unfold the model. So we enfold that experience, we unfold in terms of response. That's how complex systems work. And in that experience leading to the developing the model, then you're constantly in that interface of the possible to the actual. And then when you unfold, it's yet again anticipating, just maybe anticipating just that which will happen 5 seconds from now or 10 seconds from now, such as averting an accident. As you know, all of us, when we're driving in a car, we're constantly scanning the horizon, constantly scanning back and forth, anticipating what could happen if we don't do things properly. If we turn to the right suddenly and go into the ditch, well, that wouldn't be good. So we then anticipate that, and we then immediately correct. And so that self-awareness, that consciousness, is how we can live successfully live and avert catastrophe through that self-awareness. And so consciousness, in that sense, a fundamental linkage of the possible and the actual, is part of
Mhm.
human survival, and thus we would expect to be part of what is filtered out and encouraged in human evolution. Thank you.
Yes, yes, thank you so much.